Welcome to pH Part 2. In this video, we're going to look at how to develop a skill to calculate the pH of acids. In the previous video, we said the pH equals minus log the concentration of hydronium ions. So the little p in that formula simply means minus log. Okay, so in chemistry, when you see the P and then A and something written in front, the little p means minus log of. Later on, we will also talk about POH, which simply means minus log the concentration of OH minus ions. Okay, let's go. We are asked to calculate the pH in the following examples. The first example, we've got 200 milliliters of 0.11 mole per decimeter cubed HNO3 solution. For the purposes of calculating pH, the volume is not going to help us. We need the concentration value. This is a strong acid. This is a monoprotic strong acid. In the previous video, when we were writing ionization equations, we said a strong monoprotic acid will have the concentration of hydronium ions equal to the concentration of the acid. Okay, so we can see that the concentration of hydronium ions will be 0.11 moles per decimeter cubed. This acid will ionize and produce a single H plus, and that H plus will bond with water to form H3O plus. So they'll be in the ratio 1:1. Okay, once we get that, we now apply the formula pH equals minus log the concentration of H3O plus. And we end up with our answer of 0.96. So this calculation has been simplified because we have already talked about how to determine the concentration of hydronium ions from an acid solution in our previous video. You might want to have a look at that. Okay. In the next question, we've got a strong acid again, but this time it's a diprotic strong acid. This acid has got 2 protons to release. So it means it's going to release 2 protons, which will form 2 hydronium ions. So the concentration of hydronium ions will be twice the concentration of the acid, which will be 0.28 moles per decimeter cubed. Once we get that, it's now an issue of plug and play into the formula. pH equals minus log the concentration of hydronium ions, and we get a pH value of 0.55. The next question, we've got 1 mole decimeter cubed ethanoic acid, and we are given a Ka value. Now, to calculate the pH of a weak acid, we're going to have to take a few more steps than we did in the previous video. Because ethanoic acid is a weak acid, it's going to undergo a partial ionization, which means there's going to be an equilibrium established. And we need to use the Ka value to calculate the concentration of ions, particularly the hydronium ion, the H3O plus ion. So from this equilibrium, write the Ka expression like that. The concentration of hydronium ion and the concentration of CH3COO minus is equal. So we can replace the CH3COO minus with H3O plus like that. Then the next step is now to just substitute in the values. And then we can get the concentration of hydronium ion as 4.24 times 10 to the minus 3 moles per decimeter cubed. Once the concentration has been attained, it's now plug and play into the formula. pH is now equal to 2.37. Think you've got this? Well, it's now your turn to try these questions. Pause the video at this instance and then attempt these questions. Once you're done, press play again and the answers come like this. Okay guys, so that is how you can calculate the pH of an acid solution using the formula pH equals minus log concentration of hydronium ions. Remember to check whether the acid is a strong acid, is it a strong diprotic acid, or is it a weak acid. Once you do that, the calculation becomes easier. Thanks for watching. See you next time.